Man, in his thirst for knowledge, has always wanted to look beyond the horizon to see what is out there. To him, the sky seems to be an inverted bowl resting on a flat plate. Sprinkled over the inner surface of the bowl were the stars, arranged in fixed, identifiable patterns that did not change noticeably from day to day, year to year, or even century to century. To actually explore the night sky and make more meaning of the thousands of bodies glittering light years away, Galileo Galilei used the oldest and simplest means of observing astronomical objects, the telescope. His telescope had a very simple construction, a lens and an eyepiece. But it had a drawback. Light falling on the lens would get refracted, hence dispersion in colors could be seen. The great scientist Newton solved the problem by creating a concave surface by using a mirror which helped all the light to meet at one point. So here we are at the Science Popularization Lab at IUCAA, where we can see that telescope making can be some effort and a lot of fun.
Hi, we are here to make an astronomical telescope. The first step is to make the reflecting mirror, for which we have two glass blanks or disc of glasses, which are to be grinded one over the other with the help of abrasive called carborundum. One of them will turn into a mirror.
These bottles here have different grades of carborundum powder, which we will use for grinding the mirror. Now, carborundum powder is basically material somewhat like sand, only that it gets finer as you go on to higher grades. As you will see, this powder will be used to grind the mirror, or say, give a concave curve to the mirror, and then smoothen its surface. Now that we are all set to work, Manvi and Vinaya will take us through the complete process of grinding the mirror.
We will start by placing the mirror at 1/4 of the diameter of the tool. This is done so that the mirror's center and the tool's periphery are ground to achieve the required curvature. 120 grade carborundum is used for rough grinding. We'll count one up and one down motion as one stroke and give 20 such strokes. The number of strokes you give is not important as long as you maintain the same number throughout. What is important is to rotate the mirror to obtain a uniformly ground surface. She has just finished 20 strokes and she will now rotate the mirror through 120 degrees and give 20 more strokes. After 3 such rotations, she will rotate the tool through 45 degrees and continue the same process.
Don't forget, clean the mirror and tool faces very properly before you recommence grinding. After 2 hours of grinding, it is advisable to check the sagitta, which is the depth of the mirror. To check the sagitta, put a ruler on the edges of the curved surface and pass filler gauges of different thickness through the small gap. With different combinations of filler gauges, you can find out the exact sagitta of your mirror. Make sure you get the exact reading to get a good mirror. After every hour of grinding with 220 grade, it is advisable to check the focal length of the mirror.
Wait for the sun to be high up in the sky. This test cannot be done when it is cloudy. Hold your scale in the direction of sunlight.
Wet the mirror face and try to focus the sun's image like this. distance from the mirror face to the focused image is your focal length.
Sir, I think we have a problem here. The focal length is probably overshot.
Oh, this is all right. It's a very common problem. It is very important to check the focal length, say after 1.5 hours of grinding. Sometimes you might overshoot, or sometimes the focal length will be shorter than what was required. What we will do is, we will turn the mirror upside down, that is, we'll keep mirror on the bottom and tool on the top and start grinding. So let's go. Here I have a telescope with poorly made mirror mounted into it. And let us see how image look like. I'm going to see through eyepiece. The telescope is already pointing to some star. Oh boy, it is very, very bad. Absolutely distorted image. I can't properly focus the star. It's distorted. It's poor quality image. You know, if the mirror is not grounded properly, then what one expect to have a spherical shape, instead of that, you end up with having a crooked shape, by which all light is not focused at one point, and therefore you end up getting such a poor quality image. So it is absolutely very, very essential. You should remember that number of strokes are to be kept uniform and grounded properly while fine grinding, rough grinding and polishing. Now let us go down and see what Manavi and Vinaya are doing.
Fine grinding is more or less the same as rough grinding. The only difference being that now central strokes are given such that the blanks are over each other, so that we do not create a vacuum which will cause the blanks to get stuck. One way to separate them is to keep the blanks in the deep fridge, or otherwise hammer them out. Let's leave Manvi and Vinaya to fine grind and try to see some objects through our telescope. The best time to observe are winter nights when the night sky is very clear. This is Jupiter, the biggest planet in the solar system. With careful observation, the cloud features along with the moons of Jupiter can be seen with this telescope. Saturn, the only planet which has a magnificent ring complex, can be seen now. The moon is the most easily and frequently observed and photographed object in the night sky, and with this telescope, the craters on the surface of the moon are visible.
Ordinary glass blanks that we started off with are now finely grinded mirror and the pitch tool. We are going to polish the mirror now with rouge, which is nothing but ferric oxide, or in a very ordinary language, it is iron rust. The grinding procedure or the polishing procedure is the same as that of grinding procedure. That is, we give 120 strokes, or 20 strokes like this, 20, then turn by 120 degrees, another 20 strokes, turn by 120 degrees, and after that we rotate the mirror by 45 degrees and we continue polishing the mirror. Now let me show you how this pitch tool is made. To make the pitch tool, edge or side of the mirror is wrapped with plastic coated paper or butter paper. On this, a plastic grid is placed. The mirror is then lightly heated to make it warm. Sprinkled over it is some soap solution, and then gently hot molten pitch is poured over it. After the pitch layer is about 5 to 10 millimeters thick, the tool is placed over it. In about 10 minutes time, both mirror, pitch tool and the tool would have cooled down sufficiently. We now take them out of the water slowly and put it upside down and peel this paper out of it. very carefully. And so that not to disturb the mirror and glass, and then slowly push the upper blank out. Keep it aside and then peel this via plastic mesh, and here we have grooved pitch tool.
After polishing, the completed mirror should be accurate to 1/8 of the wavelength of light for us to get a good image in the eyepiece. Therefore, we must test how good the surface of the mirror is. Mirror is kept on the stand at the radius of curvature so that the reflection